Mixing and mastering are just about equal parts technical and creative, depending on the engineer. Editing, on the other hand, is best described as obsessing over tiny details. That really does make a big difference, though, especially since these details add up quickly. So, let's cover an arguably boring, but crucial part of making professional productions and talk about how to expertly edit your tracks. Now, I won't use any secondary software like iZotope RX. I'm just sticking to the basic functions of a DAW. So you'll be able to follow what I'm showing here, whether you're using Logic, Pro Tools, etc. Now, starting off, let's cover the biggest mistake that I see when editing. So sitting in on other sessions, I notice this all the time. There's nothing wrong with crossfades, but using crossfades without listening to the edit often causes a strange overlap between the two signals. The thinking makes sense, blending this track into the next and vice versa should result in a smooth transition, but if there's any variation between those two tracks, which there almost always will be, then you'll create an unnatural sound, in which two signals that don't match up are blended together to create a kind of strange mismatch of signals. Granted, this is why the crossfade can be adjusted, but let's be honest, most times this is a set it and forget it type of technique used to move through a session quickly. So I'll cover better methods in just a moment, but for now, let's listen to a crossfade between two different takes and notice how the blend doesn't sound natural, even though the two performances are intended to be as close as possible. Next up, let's cover how to cut and fade tracks. Now, knowing how to cut a track properly results in the need for fewer fades and smaller crossfades. The best place to cut a signal is right where the waveform is at 0 degrees. Now, by 0 degrees, I'm referring to phase rotation, not a phase shift. Semantics aside, it's the line between the peak and the trough, represented as a straight line. When you're editing, you can edit down to the sample, meaning if you zoom in enough, you could find the exact moment to split the clip. Or if you need to shorten a clip from either direction, this is a great place to make that edit. If you've ever heard a click or a pop after making a cut, this is why. The signal is high in amplitude when the cut is made, causing a noticeable difference between the signal and the silence, or the signal and another signal with a differing amplitude. So, if you want to cut a track into silence, or go from silence into a clip, this is the best option. If you're going from silence into the clip, and the change sounds like it happens too quickly, move the edit back from the intended start point slightly, and again center the cut at a 0 degree point. Then use a small fade-in that ends right at the intended start point. If you're going from a clip into silence, and it sounds like it's ending too quickly, move the cut slightly after the intended stop point. Again, placed at a 0 degree point, and use a small fade-out that begins at the intended stop point. Lastly, if you're trying to blend one track into another, a crossfade is the best option, but there's a catch. As you might have guessed from the first section of this video, this crossfade can't, or at least shouldn't, be done arbitrarily. Again, zoom in and find a 0 degree or as close to 0 degree point as possible. So, notice I'm dragging the endpoints of the track while observing the waveform's rotation. Once I find a good point where they overlap well, I'll create a crossfade. If it's a stereo track, it might be more difficult since you'll need to find a good compromise if there are no points where they overlap at 0 degrees. Maybe the left channel does, but the right doesn't, or vice versa, but just use your best judgment and find the best compromise. I might be thinking at this point, well, why not just use your ears? This seems annoyingly over the top, or like I'm mixing with my eyes. You can kind of use your ears for something like this. Either you'll hear a pop or you won't. However, you really can't hear less than 1 millisecond of change and think, well, that's not properly aligned and I need to move it 20 samples to the left or right, unless you have superhuman hearing. I personally don't, so I look to see where that alignment will work best. Once you find the best cut, use a small crossfade. The bigger the crossfade, the more unrelated signal you'll blend together. A tiny crossfade placed at the best point will always sound better than a big crossfade if you're going for a seamless cut. So let's listen to some edits real quick. I'll cut clips at 90 or negative 90 degrees and notice how the edit is pretty audible. Then I'll make that edit at 0 degrees and notice how much smoother the transition is. Then we'll compare a crossfade done poorly with one with the method that I just showed here. Make mixes that accurately translate what you hear in your head without years of practice or expensive plugins. Seriously though, when people work with us, they get results. That's why major industry professionals like Keith Urban's producer Aaron Schurz works with us, Grammy Award-winning AJ Castillo, Billboard #1 charted artist Megan Lindsay, Grammy Award-winning artist Toulis, The Voice singer Cody Ballou, Grammy-nominated producer Tyler Kane, Warner Music artist Ricky Young, and the list goes on. Why waste your time creating mixes that look like this when you can instantly fix the problem by working directly with professionals who have already done what you're trying to do? Watch this entire video, and at the end, learn how you can start making mixes that accurately translate what you hear in your head. Next, let's cover using LUFS normalization. So this technique doesn't work in all circumstances, but if you have a performance that varies greatly in loudness, yet it's supposed to be consistent, it works well. For example, if a vocal performance during the chorus varies between sections, you can isolate the clip and use LUFS or loudness normalization to bring it up or turn it down. First, find a section that's the intended loudness, or determine what you want the loudness to be. Typically, you'll want the peak to be around -5 dB or so that you could add some additional processing later. With that value determined, isolate the sections that fall below or go too far above it and normalize it to that LUFS. Now you might be wondering, why not just use peak normalization? Well, peaks can vary greatly and aren't a good indication of consistency. For example, maybe the vocalist sang something too loudly in a section, and now peak normalization is using that part to determine how much gain is needed. If that's the case, which is pretty common, peak normalization isn't going to be a good option. Now once you perform LUFS normalization to a larger section of the performance, go back and listen to fine-tune the changes. LUFS normalization uses clean gain to make changes, so it's pretty easy to bring the gain up or down as needed. It could be slightly time-consuming, but it's a great method if you want consistent performances and you're trying to avoid processing like compression as much as possible. Let's take a quick listen to this editing method and let me know in the comments if you plan on trying it yourself.
Bar fights and sleepless nights, another day's another blur. Bar fights and sleepless nights, another day's another blur.
Last up for this video, let's cover editing exact notes. So say you're editing a vocal, a bass, guitar, piano, and so on, and you want to isolate a single note. Maybe you want to use it creatively, or you want to fix a mistake in the performance, etc. How can you be sure that you've properly isolated the note? Now, fortunately, this is easy to do, again by observing the waveform. First, you could use your ears to find the relative area of the note. Then, zoom in. In this example, I have a bass part and multiple notes that are occurring in a short period of time. By looking closely, you can see where the note changes. The denser the oscillations, the higher the frequency. So, say I'm going from a lower pitched note to a higher one. I can find exactly where the notes change by finding where the oscillations change from spread out oscillations to denser oscillations. I could do the same if it's going from a high pitch to a low pitch. You'll easily be able to see a difference. Again, once you find where that occurs, create the cut at a 0-degree point. This is also super helpful for unmusical aspects of a performance. So, say the vocal has annoying sibilants, like a DS, but say it's so aggressive that the de-esser is having to work too hard and now the processing is becoming audible. By zooming in, I can find the points at which the performance changes from a note to higher frequency sibilants. It's easy to see you'll have oscillations that are a bit more spread out and indicative of a lower frequency. Then, a super dense cluster. The dense cluster is the sibilants. Once I cut at 0-degree points around the sibilants, I could use clip gain to attenuate it. The process will be slow at first, but like everything, the more you do it, the easier and more natural it becomes. So, let's take a listen to a vocal track that I've designed to artificially have annoying levels of sibilants using frequency-specific expansion. Then, I'll carefully isolate the sibilants and attenuate with clip gain for a more balanced sound.
Bar fights and sleepless nights, another day's another blur. Bar fights and sleepless nights, another day's another blur.
Make mixes that accurately translate what you hear in your head, without years of practice or expensive plugins. Seriously though, when people work with us, they get results. That's why major industry professionals like Keith Urban's producer Aaron Schurz works with us, Grammy Award-winning AJ Castillo, Billboard #1 charted artist Megan Lindsay, Grammy Award-winning artist Toulis, the voice singer Cody Ballou, Grammy-nominated producer Tyler Kane, Warner Music artist Ricky Young, and the list goes on. Why waste your time creating mixes that look like this when you can instantly fix the problem by clicking the link in the description and working directly with professionals who have already done what you're trying to do? We've helped 2,346 clients make mixes that accurately translate what they hear in their heads without years of practice or expensive plugins, and it'll work for you too. Click the link in the description and get direct access to us for custom analog mastering, one-on-one mixing feedback, in-depth mixing and mastering courses, and our thriving community. Click the link in the description now to start making mixes that accurately translate what you hear in your head.